Hi, this is Mr. Ward, and this is the Algebra exit ticket 34.2 if you're in A and B block, or 34.3 if you're in D block, video key. Let me expand my screen a little bit and let's go. So we want to factor x squared minus 64. If this is still challenging to you, I want you to really spend a little time exploring the concept of differences of squares. So here's a difference of squares. A squared minus b squared. And so that's just two squares, and I'm getting the difference of them. That's why it's called a difference of squares. Now, to get the factors of a difference of squares, you simply get the square roots of both squares, and you have one factor where you're adding those square roots, and the other factor where you're subtracting those square roots. And that is how you factor a difference of squares. So let's consider this. So we've got x squared minus 64. Okay, the square root of x is x. I'm sorry, the square root of x squared is x. Okay, and the square root of 64 is 8. So x plus 8. We add x and 8, and we subtract 8 from x as well. Okay, it doesn't matter whether you did x minus 8 times x plus 8. You can reverse multiplication, of course. But that is how you get the factors of this difference of squares. By the way, the x-intercepts would be negative 8 from the x plus 8 and positive 8 from the x minus 8. Now we want to factor x squared plus 16x plus 64. And you might notice, hopefully you're noticing there's a perfect square here and there's a perfect square here. At this point, you want to be suspicious of a perfect square. If you're not noticing that yet, you should review how to recognize a perfect square. So a perfect square, if I have a plus b, and that's squared, that's the same as a plus b times a plus b. And when I do that, I'm going to have a squared, so a times a, so a squared. I will also have an a times b. I'll have a second a times b, and then I'll have a b times b, which will be b squared. Okay, and the a times b plus the a times b can be put together into a 2ab. So we've got 2ab. If this had been minus, I would have a negative ab and a negative ab, and there would have been a minus 2ab. But this is what we have here. So just think in terms of what would a be if this is a squared. So in this case, the a would be just x. And we go back to this structure here. So instead of a plus b squared, let's say the square root of x squared. So that's just x. And instead of b, we're going to look at the square root of 64. The square root of 64 is going to be 8. There is, of course, a negative square root, but in this case, we're going to be looking for the positive square root, because x plus 8 squared will equal this. And part of how I know that is 8 is half of 16. I've got a 1 here, so I don't have to worry about any extra details. All I need for my last term is half of 16 squared, and half of 16 is 8. Now I'm going to go ahead and multiply this out just to prove it. X plus 8 times x plus 8 will be x squared from the x plus x times x, plus 8x from the 8x, plus 8x from the other 8 times x, plus 8 squared. And 8 squared is going to be 64. And 8x plus 8x is going to be 16x. And there you have the whole thing. So this middle term is going to be 2 times the product of the square roots here. So the square root of x squared times the square root of 64. So that's x times 8 times 2. X times 8 times 2 is 16x. So whenever you see a perfect square in the front and the back, start being suspicious that you might have a perfect square. And that right there, this is the factoring of it. You could have written it this way, but this is actually quicker, x plus 8 squared. Okay, let's think about which one of these would be a simplified version of the square root of 45. So when you're getting a square root and you're trying to simplify, it's useful to break the number you're getting a square root, down into its factors. And 45 is 9 times 5. And we can get the square root of 9. Okay, so the square root of 9 times 5. So the square root of a product is the same as the product of square roots. So we can turn that into the square root of 9 times the square root of 5. And the square root of 9 is going to be 3 plus or minus 3, of course, and then square root of 5. Okay, let's take a look at number 4. So you've been reminded that the standard form, reminded you on this a few do nows in a row, so hopefully this is becoming a bit more familiar for you. So ax squared plus bx plus c is the standard form of a quadratic. Many types of equations have a standard form. This is the one for quadratics. So what are a, b, and c in this equation here? Okay, so I'm just going to copy this here into here. And so I know that x squared is times 1. So a equals 1, not 1x squared, just 1. And b is going to equal the coefficient here of just x. So it's b is negative 6, not negative 6x, but just negative 6. And c is going to equal 9. And we are done. I hope that was helpful.